Exercise 6i, determining rules for graphs. Today we are going to learn about finding the rule of a circular function, and what you need to be able to do is to identify key values from the worded problems and then substitute key values into the equation to be able to find the circular function itself. Now, just as a reminder before we start our examples, what does the circular function look like? Well, we've got y equals, and it'll either be sine or cos at this point. We've got the amplitude at the front. We've got the n value, which is our dilation, and then t. Of course, we can also have translations. So inside the bracket, we could have minus k, and then plus k, which will also be our translations. So you just need to be able to watch out for each of these. The amplitude, what the amplitude simply is just the difference between the average value, which is this point, and the maximum or the minimum. And our n is not the period, but our n gives us our period. So 2 pi on n will be our period. And n is the dilation factor that leads to that. So just keep these couple of ideas in mind before we begin. So example 15. A function has the rule f of t is equal to a sine nt. The amplitude is 4, the period is 12. Find a and n and sketch the graph. So this one's a very straightforward question because they've given us the answers really. So in terms of the amplitude, that's very straightforward. I can plug that straight in. So that means our amplitude will be equal to 4. Now here is a key error that people make. N is not equal to 12. It's the period is equal to 12. Now what is the formula of the period? That's 2 pi on n, which would be equal to 12. Now we can go ahead and solve for n. So we can swap them. So that will be dividing by 12 and timesing by n. That means n is equal to pi on 6. So now that I have that information, I can write out my equation, which is going to be 4 sine pi on 6t. In terms of sketching the graph, this one should be a very straightforward graph to sketch. So it's a sine function with no translations. This case will be t and f of t. So just be careful in terms of labeling your axes. Now our maximum and minimum is going to be 4 and negative 4 because that's the amplitude, and then it's just a sine graph. Just want one cycle. Whoops, let's try that again. So it'll look something like this. Now we know the cycle is 12, the halfway point is 6, and this point will be 3. So I'm going up in intervals of 3. So it'll be 0, 3, 6. So this will be a 9. And that will be your graph. Next question. A function with the rule y equals a sine nt plus e, or epsilon, has the following properties. The range is between negative 2 and 2, the period is 6, and when t is equal to 4, y is equal to 0. So from this, we've got information that's going to help me find both the amplitude and the period, and that last value there is going to help me find my translation through substituting in an unknown point. So let's just focus on the amplitude at first. So as I mentioned earlier in this video, what is the amplitude? Well, it's the difference between the average value and either the maximum or the minimum. Now in this case, we know that the maximum is 2 and the minimum is negative 2, which means the average has to be in the middle of that, which would be 0. So what does that mean for my amplitude? Well, it's going to be the difference between these two. The amplitude must be 2. So it really helps to draw a diagram to be able to see it. Now in terms of the period, it's very similar to what we had before. So again, we know that the period is 6, not that n is 6. So the period is 6, which is equal to 2 pi on n. That's my formula, and now we solve for n. So we can take n to the top and 6 to the bottom. That means n is equal to pi on 3. So I'm almost there. I just need to find epsilon now. So what we can do is substitute in the values that we know so far. So that'll be 2 sine pi on 3t plus epsilon. And then in order to be able to find that, well, we've been given a point. So let's substitute that in. So what I know is that when t is 4, y is 0. So just keep that in mind in order to substitute that in correctly. Okay, so now what we're going to do, I'll just zoom in a little bit. Oops, can't seem to zoom in. All right, there we go. So now let's try and solve this. What I know is that I can simplify this to be 4 pi on 3 plus epsilon. I can divide both sides by 2. which would just be 0, and then I could take sine over to the other side. So the way to do that is you would take sine inverse of 0 is equal to 4 pi on epsilon. Now what is sine inverse of 0? So if we were to think about our unit circle, where is our y value 0? It's over here, and sure, it's over there. But just so that we can keep it simple, we'll always take the smallest value for our rule, because it doesn't really matter which one we used. We'll get the exact same answer, but we will take our smallest value. So sine inverse of 0, our most simple answer is 0. And from there, I could very easily solve for epsilon, because that will be negative 4 pi on 3. So there you have it. That is how we can find our 3 unknowns. So that's our amplitude, our period, and our translation. And that's it for this exercise.